We need, of course, take into account health, security, well-being, and also never forget, I told that at the beginning also, it's just a reminder, lighting change our aesthetic appreciation of an object, of a person, okay? Then you have to take into account some other constraints, which economic and regulatory, energy consumption, environmental impact. We speak about environmental impact in the following lecture. Take into account all the cost. And here I'm speaking for three kinds of cost. Initial installation, operation. Operation is how much energy you use for that. And finally, maintenance cost. Maintenance cost can be very important also, and smart lighting can reduce, efficient lighting can reduce operation cost. Smart lighting can reduce maintenance cost if you can monitor the status of the system and add some self-healing functions, but both of them increase the initial cost. Then I will not speak here, but normally I could have another session, another lecture on lighting economics, and show you how you need to calculate the return on investment time when you propose additional options to your systems. But we don't have to do that. It should be affordable and also take into account all the laws, regulations, standards, policies. Yesterday you had an overview, a very rapid overview of all that ecosystem. And finally, this is interesting, of course, for people from architecture. And when I'm speaking here, architecture is not only building architectures, but it's also interior design. It's under the same title. Then you have to take into account the shapes of the objects or buildings that you have to eliminate, the composition, what are the materials that are used to create that objects, the style. You will not eliminate the same way a Hindu temple with a Orthodox or a Catholic church, or with I don't know, a modern building, okay? Shadows. Shadow is very important to give the impression of volume. And finally, of course, colors, okay? You see, really, a lighting designer, a real lighting designer has to take into account all that beyond the technology. The technology is what offers the possibility to create a lighting system to the designer. Lighting strategies, we're speaking here about indoor, and we stay to indoor. There are different lighting strategies. You can see here two different spaces, one working space, another one more relaxing space is at home. But in both cases, if the needs are different, you have some general things that are the same. First one, you have that we call the general lighting, which is provide the lighting everywhere in the space. Okay, the trophers here, the fixtures, they provide in general lighting. Then you have task lighting. Task lighting, for example, here you have task lighting. This lamp here serves to see what is on the small table, or you can imagine here that you can add this small lamp. This is task lighting also, to illuminate better here. Task lighting, of course, is movable, and it is very localized. This one is general and is there from the beginning, and it is very difficult to change. Then you have mood lighting or accent lighting that is needed to highlight objects. Here is the case. This is accent lighting, highlights the chimney here. This is the idea. And mood lighting, I don't have here any mood lighting, but this one can be considered as mood lighting or ambient lighting here. And here you have also accent lighting. You illuminate, for example, the whiteboard there in order to see it better. Okay, this is the different type of lightings that you find in all spaces. And then there are different concepts how to design the needed lighting. This is an American concept, the design lighting in layers. I like that very much, but you have to be very careful because you can overspend energy if you don't take into account energy considerations. What is that? It's like an onion. Create light up your space layer by layer. And there are three main objectives that the lighting system must take into account is illuminate, create areas of interest when necessary, and guide or orient in the space. You have those three functions, and in fact, when you want to light up this room, you say what is the most important. You decide, for example, that illuminate, here is the case, is the most important. And then you start by design the lighting to respond to all needs from general illumination. Now, if you are in a corridor, there is a very important function beyond illuminate is guide and orient in the space. Then you say first layer is light generally, the corridor. Second important function to achieve is guide and orient, and then you have to add some additional lighting in order to obtain the orientation or try to combine both. Okay? If you go to a retail store, of course you need to illuminate. This is one function, but you need to create a point of interest if you want to sell something specific, or in the opposite, if you want to sell everything, you need to avoid to create point of interest. And I will say maybe for a store, this one is maybe before illuminate. And also guide and orient in the space, of course, in that case is very important. You see, you have to take each space and say, what is the priority that I want to give to each layer, and start by designing that layer, respecting all the constraints, and then you add the next layers up to finalize your design. And why I said this is can consume more energy, because designing by layers, each time you add new lighting systems, new light sources, new power consumption. And if you don't take into account that, you can overspend, okay? But the idea behind is, or you can combine and then limit the new light sources that you will add for each layer, or you can play with the use time and reduce again the lighting. For example, guide and orient in the space in a corridor should stay on in any case. This is emergency lighting. Even if you have a problem inside the building, then illuminate is necessary only when person they are present. Okay? Let's continue. Light has some magic power. This is has the power to reinforce the volume. You feel to be in a larger volume when you have a uniform peripheral lighting. If I eliminate just the periphery here and you have less light in the middle, then I may create the impression that this room is larger. You can reinforce the impression of visual clarity. This can be done by lit peripheral lighting, cool light, and high luminance level in the central horizontal plane. For example, if you enter your office and you see your desk over illuminate and you have a little bit light around, you create like a light cocoon, and you have the impression that you see better in the central area. It is an impression, is not always true. You can reinforce the feeling of relaxation that is for our homes, for hospitality premises, and that you can do it by using non-uniform peripheral light and warm light. Warm lights, remind you, allows melatonin to increase, maybe not so rapidly, but makes you feeling cool. And why warm? Warm feel you cool. This is very nice opposition of the words, but you have to understand that. And also when you need shadows and not only uniform lighting, when you have a very uniform lighting, you feel to be in a hospital room or even in a surgery room, and you don't want to have that. And finally, reinforce the impression of private space. You can create, as I told you, light cocoons. If you are inside, you are in a cubicle, or you have in an open space office, privacy is very difficult, but if in the late evening you over-illuminate each working area and you don't give so much light around, you have the impression to be in your own light space, in your own light cell, and you feel more comfortable. But the contrast, I remind you, between the illuminate area and the other has not to be more than 10 times, because if it is more than that, if the surroundings are very dark, you will feel not very well, because you can have always the feeling that something wrong can go inside the dark space, and you need to stay alert. Okay, let's now try to apply all those principles, and that will take us maybe till 11. Let's look what kind of lighting I need in different kind of premises. Well, I will not speak about homes, because in homes you don't have any obligation. You do what you need, what you want, and no one can force you to change. The only thing that is important for housing is to use how to say energy efficient products in order to avoid to pay your electricity invoice at very high level. And when you use energy efficient products, you reduce your invoice. You may pay a little bit more expensive the lamps, but then you have a return on the investment that usually is in the order of few months. Okay, let's start with office. Here, you have here, I will not go line by line. You have here different standards, tell you how much lux I need here. Sorry, something is missing. I don't remind what is there, but this is the color rendering index. That means, look, you need something like between 300 and up to 750 lux, which is dedicated when you have a technical drawing. Okay, if you are just doing writing, typing, reading, 500 is enough. If it is a reception desk, 300 is enough. If it is archives, and you don't need to have more than 200. And also you have some special configurations. For example, is here in conference room, 500 lux, they are enough. Lighting should be comfortable in order to avoid to sleep people. Here, if I measure the light quantity in that part, maybe we are not in 500 lux. We are low than that. There is something always interesting to look. I remind you that we speak about ergorama, panorama, and the liaisons between those two. There is the case of office. What are the points of attention here? Well, you need first surface illuminance in the desk, okay? And in that case here you have to avoid strong contrast. That means here and maybe all around you need a very nice spatial uniformity, and 80% is the value that usually we ask for that. You need to avoid any direct glare from windows, for example, here, and you see the cubicle cuts the direct vision to the window, but also you have blinds that can be controlled by the system in order to avoid that direct sunlight is coming inside. And direct glare is the same. You have to avoid, for example, here to have reflection in the screen, and you see that the fixture above is behind the screen. This fixture can provoke direct glare, but you need to move the head, but avoids to create here and direct glare. You need to have control lighting, natural lighting. I spoke about that, and everything here is important. You have to take into account if this is dazzling or not. What happened with the natural light? How much natural lighting you have? Maybe add some sensors in order to take into account the presence, take into account the quantity of natural lighting, and so on. And you need also to take into account the luminance going to the different surface and the characteristics of the surface, because this wood reflects a given quantity of light, this one another, that one another. Well, when you select the different materials or the different colors, you have to take into account that the light coming from above will be reflected by those materials, and this is what you will get in your eyes. The paper has a different also reflection coefficient. In fact, you have to avoid high reflection coefficients, because if you have high reflection coefficient and specular reflection, then this is the case of the mirror, you create bright spots that can attract your attention, or in extreme cases they can create glare. Glare control. In fact, I remind you this scheme. This is the more glaring fixture. For me is that one. For you, most probably, is that one. That is the further from your light of sight, and you need to just to move your eyes. This one I need to move more head, and I don't know many people beyond lighting designers that are looking at the lamps. And I explain you how to calculate all the stuff, looking in the catalogs of the lighting designers. But here, in a general situation for office space, we consider to have less than 19 of UGR, Unified Glare Rating, and then one general rule is avoid to have any kind of fixtures if you don't have access to the characteristic of the fixture. Avoid to have any fixture in an angle here higher than 65 degrees. This is doable if the room is rather small. If the room is very long, then it's another problem. But if you have a very long room, you have two possibilities. Or you put the desk following the depth, or you put the desk following the larger part of the room, and you have to design even the position of the desk if you cannot play with the lighting system. Let's go now to educational premises, schools, universities, and things like that. I remind you that for protection index, IP index, there is clearly a distinction between kindergartens and all the remaining, because the kids, young kids before 6 years old, they may have special needs to protect. Of course, you have to avoid to have really any kind of lighting accessible by the kids, even if they climb in the tables. But in any case, you have to have IP at least of 3. At the beginning 3, something else behind. It's fine. This one not. Who can tell me why? Why I told that this one is not a good idea? in the whiteboard, you have a reflection. That means the student or the people still sitting there, they cannot see anything when I write down there. Otherwise, both they are very uniform. On the other hand, there is another problem. This one, you have almost zero contrast between the roof and the wall, and this is not a very good point. Here you have a little bit more contrast, and especially you have best contrast with the floor. Okay? Visual tasks must be fairly specific. Learners are usually seated and looking at the instructor on the board or projection screen. But then you have on the other side, here you have me, you have the teacher, and the teacher has different needs. And I remind you that all standards, when they give values for the maintenance luminance, for the uniformity ratio, or for the glare, they are concerned the employee, and the employee is the teacher. The learners, they are the clients. Everything has to be designed in order to simplify the life of the workers. This is the only thing that is imposed by standards. And of course also it's preferable to avoid that you kill your clients, or if the clients they are not happy, they will not come anymore. And this is also damaging for for that. And you see each time that even inside educational premises, we have to take into account the different use of the space. You have the general teaching space, you have a teaching space with close detail work that can be arts, craft rooms, student labs, for example, especially if you do if you manipulate teeny elements, or if you have chemistry labs that you need to see different colors and things like that. Then you have the circulation space, and also inside these premises you can have atria, you can have also some catering space, relaxing space, and you have also, of course, the office of the teachers. But the office of the teachers, we need to refer to the previous thing. We are speaking more about office than about education premises. There is some things to take into account. Once again, you have different values for playrooms, nurseries, handcraft rooms. This is more for primary schools. And then you have to look what is the more important here. For example, the light on walls and ceiling is very important for general classroom, is very important for classroom, is less important for the corridor, because, as I tell you, if you design your lighting by layers, the light coming to the walls and the ceiling is important for general lighting. In the corridor, you need general lighting, but the most important is to have guidance, guiding in the space. And then control of glare, same thing. Uniformity. Uniformity is very important for computers. For classrooms, less. Daylight. Absolutely you need to have daylight inside the classrooms. But you have also to avoid that the kids, they are looking from the window. In that case, you will use opaline windows, or windows that they are not allowed to see outside, and you get only the light coming out from the room. But you have always to have a window clear that the teacher can see what happened outside, in order to avoid the problems, any kind of problems. Okay? In computer room, you don't need absolutely not daylight, because daylight, remind, screens, when you increase the quantity of available light, overlight, you destroy the contrast, and in that case you have lower visibility level. That means, yes, avoid to have direct daylight inside the room. Corridors is okay. Color rendering and color temperature, well, it is not so important for the classroom. It's very important for the computer room. And less important for the classrooms. And lighting controls, yes, here you absolutely need lighting controls because they are the areas that a stain eliminate as much as possible, and they are also the areas that you have large quantity of daylight, and then you can control the spatial distribution of daylight. For computer classrooms, less, on-off, presence or not is okay. For school corridors, you don't need at all because the corridor has to stay on at any moment when you have users inside the premises. Because always in a corridor you have to find your way even in case of evacuation. Okay, you see here you can write requirements for the tables, for the projection screens, and for the practical areas. That means someone who will design a lighting system for a school has to take into account all that and has to adapt the lighting system to each space inside the school, the university, and things like that. Libraries stay at education level. Libraries also are very important, especially for universities, because in libraries you have two spaces. You have the space with the books, okay, and then you have a working space for the students. I don't know what are the habitudes in India, but in France, for example, in the university library, we have place that the students can reserve, and they can go for working in group. While in US, it's very often that you have students working in the university libraries. You can see that to any US film. And also inside this kind of premises, you may have a very modern one, and you have a very old one. If you go to old universities, you have very cozy environments, and the way that you will light up for an architect is not or interior decoration guy is not the same here than here. And then you have the needs for the work. Usually, in fact, here you don't see it, but usually in US libraries, you have a task lighting above the tables, because you need to add lighting. And you have not to forget that books, they are not in horizontal position, but they are in vertical position. And that means you have here, for example, you needed to be able to have the same quantity of light here and on the bottom and the top of the shelf. Also here you have the books. If they are modern books, it's okay. If they are old books, they don't like exposure to a lot of daylight or to aggressive light with UV or infrared. And of course, if you have a fire, books, they are flammable. That means you need to have fixtures that can afford potentially a fire inside a library. Hospitals. Okay. Hospitals, as I told you from the beginning, much more complicated because you have different spaces, doctor office, waiting areas, bathrooms, may have libraries, first aids, corridors, kitchens, laboratories, operating rooms, dentistry rooms, maternity wards, patient rooms, and you can imagine much more. And each time you have different population concerned. Only the doctor, nurse, and things like that, they are the employees. All the other, they are the users, and they have their special needs because concerning the different type of illness that you are to treat there, you need to take into account. And you see here, for example, what type of lighting you need. You need the general lighting here and working also on the working table. You need different kind of lighting and different level of lux illuminance level. Same thing here. And then if you just take rooms, common places and surgery rooms, the needs are completely different between them, because here you are more in residential configuration. Here you need to take into account general and task lighting. Here you are in circulation, you need to indicate the way, and here you have something very specific. You need task lighting mainly. Operating rooms, they are very special, because surgeons, they have to see very well what they are doing, and that in a very small area. When you take these lights who are specific for the surgical room, they are not general lighting, it's task lighting, and the surgeon can move it, focalize one where he wants, and you have to know that in a spot of 20 centimeters, you may have up to 20,000 lux, because the surgeon has to see exactly what he is doing, especially if he wore lens to see the details. Today also, sometimes they have to look the screen, they have to look all around, you have to take into account. But it's not unusual to need 20,000 lux, and that you have, it's very funny, but as those lights are usually coming from behind, well, not some, a lot of surgeons, they are complaining to have calvicy problems, because they have very strong light hitting their head, and maybe it may affect the quantity of hairs. Well, but they need such quantity of light. For me, it's not really useful, but they learn to do like that. And something very important also, surgeons, they learn operate with a given color temperature. And this color temperature may be different from one surgery school in one country to another. And the problem is, they are dealing, for example, with shades of red, because blood is red, and the difference, so small difference in the color, red color shade inside the area that they operate, could be very important when they are looking, for example, to get out a cancer, a tumor. The color difference that the doctor perceives is very important for him in order to see where are the limits. And if you have learned to operate with cold white, you will not see the same reds. And if I put you now in an operating room with warm white, it will be a catastrophe, because the doctor is not trained to operate under such lighting conditions. That means this kind of light here is very specific, and usually can be completely different from one country to another. Initially, surgeons, they learn, I'm speaking beginning of surgery, beginning of 20th century, the operations went only under daylight, never the evening. Today we can do everything, but yeah, this is, and uniformity, of course, is very important, because if you have shadows may distort colors, and this is also problematic. Color rendering here is very important. Okay, let's leave now hospitals, and let's go to factories, warehouses, and things like that. Offer significant difference from one building to another. It depends what kind of factory you have. You cannot treat the same way a wood factory with a cement factory, or I don't know, or a chemical factory. But there are some common characteristics for those premises that usually you have great installation heights, you are in a space, very large space, and the problem is that your lamps, they are far from the surface that you need to operate. First thing, in that case, most of the lamps, they are suspended. They are very seldom on the roof or recessed. Normally, we suspend the lighting, and the usual suspension height, if it is possible, is 1/3 of the height of the space. This is the usual one, but it's not always here. But here you can see that the lights are there, and they are suspended, okay? And then something that you have to take into account is very often you have dust and humidity present in the room, and then you have to add also some flammable or explosive constraints and things like that. But always, to eliminate such areas, such volumes, it is very consuming in energy. Here, energy constraints, they are very important. And as the luminaires, they are far, they are used for general lighting, and then you need to add, following the situation, task lighting. And don't forget that you have a manual task inside, manipulating maybe large mechanical parts, or in sometimes small parts, and they have screens that they are exposed in dust and all that stuff. Well, you have to not only to think very well when you conceive, you design the lighting system here or there, but always you have to think also about the program maintenance of your system in order to maintain the system in the good operating conditions. You see some illuminance levels. You can go to very high illuminance when you are do a fine work inspection, precision assembly, and things like that. It's not the same when you are working in a metallurgy factory and when you are working in a electronics device assembly factory. There are some points of attention that they are common to all of those space. First, you need absolutely to avoid flicker, because flicker, if you have moving parts or rotating parts, can generate stroboscopic effects. If you have something rotating, and if your light flickers at the same frequency, then you can perceive the object as stationary. And if you put your hand inside, could be a big problem. Imagine journal printing premises. You have big factories with rotating parts. If you don't see that the thing is rotating and you go to take a part of the journal and you enter in, you will go out from the other side kebab style. Well, it is better to avoid such problems. You need to and avoid the dark space behind the luminaires, behind the fixtures, as the fixtures, they are deported from the roof. Then you have a part around the room that can be very dark, and this high contrast between the illuminated part and the dark part can create not very acceptable feeling of the space. Of course, you need to avoid a direct glare. You see here, we don't have windows. We have that we call sky windows. They are higher in order to allow direct daylight to enter in the place, but never at the high of the eyes of the worker. You need uniformity, because it is difficult to recognize details when you have dark and very highly illuminated areas. and you need, of course, to avoid also shadows. Okay, high uniformity, most probably high quantity of light. Avoid any glare from there or from the windows, or even from reflecting materials on the working areas of each employee. Yeah, okay, I will not comment that. For example, for color, here is important. For cashier and circulation, no. Contrast, accent, highlight here is very important, not the opposite, and so on. Even inside the retail space, you have to organize the subspaces with different light quality and quantities. There is some point of interest. First of all, the luminance level. Usually you have also high, high in the premise, and you need high ceiling luminance to increase the uniformity. Ideally, if you can have access to skylight, could be very nice because this is free, but in any case you have to put usually very large number of fixtures inside the room, inside the space, in order to have uniform distribution of the horizontal luminance or illuminance, maybe. Well, it depends, however, what kind of more that stuff and less that one. You want to sell everything with the same preference for the customer, special promotional products. That means inside here you don't have any interest to have a huge difference in the contrast in horizontal level, because if you have different in the horizontal contrast, you will attract people to more lighted areas. It could be true, for example, here, if you want to create a point of interest, because it's the special selling of the week, and you need to attract people to buy that stuff. Same thing also, you need to take care of not only the horizontal but the vertical, because the shelves, they are vertical, and same thing, you don't want to sell less that product than that one. If you have a different quantity of light vertically in the shelf, you will attract the eye of the customer to the more lighted part of the shelf, and this is not correct. You need, of course, to avoid direct glare. Usually you don't have windows. You may have skylights, or you have fixtures. Customers, they don't look the fixtures, and when you have projectors, they are very seldom oriented to the high of the eyes of the consumers. But you may have glare from reflecting parts. If you have high reflecting products, they may create glare, and you have to take into account, especially if you highlight here the product with projectors. You need a good color rendering. This is very important, especially when you want to sell fruits, any vegetables, because the content, usually in an office, in a school, 80% of CRI, 80% of CRI is enough. Here, for areas, products, especially vegetables, fruits, flowers, you need a CRI, fruits, flowers, you need a CRI going up to 95, because the colors, they are very 95, because the colors, they are very important. Okay. When you go to some other areas inside the supermarket, especially if you go to butcher area, you will see that the meat is usually illuminated with pinkish light. Here, the pinkish light has been calculated such way in order to make the meat color more attractive for the user. And what happened? You buy a steak, or I don't know what other, has a very nice color, looks very nicely, and you go back home, you open your steak, and the color is not the same. And if in meantime outside was very warm, you can say, due to the warm space, I deteriorate the meat. No, the appearance of the meat was exactly the same to the two sides, but the color of the light has been selected in order to make the meat more attractive for you. And of course, you need to create a bridge or point of interest when you want to sell something specifically. This is for supermarkets. You want to sell everything same way. This is a Lux retail stores. The problematic here is completely different. They don't want to sell maybe 10,000 products per day. They want to sell maybe 2 products per day or per week, but the price that you will pay is much higher. And there you need to create very cozy ambience inside the space, but you need this is to attract the client in. And then where you are in, you have to illuminate the objects that you want to create to a very specific fashion. You see here, for example, if you over illuminate here the object here, you go directly there. Here also, playing with the scenography or the shadows and the colors, you can create that we call dramatic ambience, and this is very important to attract people to buy those objects. Just to remind you, if the contrast between this area and that is 2 to 1, that means this one is 2 times brighter than the remaining, it's just noticeable. This is good for a general store. If it is 10 to 1, it is significant, and this 100 to 1 is dominant. Here is the case. This one is dominant. I enter that room, the first thing that I see here is that. There, this dress, we are most probably around to a contrast of 10, and this is significant, that is enough to attract your attention. And of course, here, as I tell here, accent lighting is very important, and also color rendering and contrast are essential. You don't like to buy that dress, has a given color, and when you go outside, you see a different color. Hotels, we are here in hospitality. Hotels, they are also special because you have different space. You have the common space with the reception, and there you have workers, and then you have the private space for the rooms. And here you need to have working but cozy ambience. It depends on the quality of the hotel. Higher the number of stars, more cozy ambience you need here. And you need inside the rooms relaxing ambience, and also the possibility to change the intensity of the light, the direction of the light, or what you light up, the color of the light, why not also, in order to create different ambience. And well, there are some indications how to light up different spaces, and what kind of luminance level you need. Sometimes you may have glare problems inside the rooms. Glare is maybe not very important. Of course, you don't want to have the light just in your front, but you need to have ambient lighting, task lighting. And if general lighting is missing inside the room, it's not so problematic. Restaurant. Here we are in a completely different domain. Restaurant, you need to create ambience first. Waiter show you your table with a small projector, which is the lamp of his phone. But you need to have a very, especially for high-level restaurants, very cozy and warm ambience. Remember the famous Kruithof diagram shows that you feel very comfortable if you have a very low illuminance level associate to very low correlate color temperature. Illuminate that space with candles is fine because candles is very low color temperature and generate very low light. Okay, very low illuminance, and you are happy, except when you try to read the menu on the cart. In that case, you need to have a task lighting to see a little bit more better what it is written there, and especially also the price. Okay, you have some indications. On-site gaming kitchen in the restaurant room, and I forgot here something very important also. Beyond the mood is also the color rendering. You need very well what you're eating. If you eliminate a tomato with blue light, you will see if it is a small tomato, you will think that is something else. Well, if you don't see the right colors, you can be very influenced, and there was some tests made around 70s that shown that if you take 2 or 3, well, you take few people, a sample of people from different origins, things like that, and that you tell them, please refrain to eat something for a full day, and then you are starving, and they serve you, for example, it goes in US, nice thick US steaks, illuminate with different colors. And what happened? Some steaks illuminate with green. People said, this steak, the taste, and also the odor is not good. The steak is passed. But it was exactly the same to all people. But the lighting can completely change also other feelings like smell and taste. We call that eyes and vision is a predominant sense that may affect the others. Yes. Sorry? Oh, you can use today very high CRI LEDs to do that with warm white is doable. CCT here CCT is well below 3000. No, if you stay around the black body locus, with a small deviation allowed the black body locus, you can defy the CCT. The CCT here is around 3000, 2700 in this fissure here. No. You can get CCTs with completely different spectral distributions. It is not an obligation to have a dominant spectrum in LED, in red, in order to have a low CRI. You can obtain the same CRI with different spectrums, and you can obtain the same CCT with different color temperatures. Those different spectrum also. Today, I remind you that CRI, we try to ban it. We want to create a different matrix, which is the color fidelity index, and the color fidelity index is based on the illumination of 98 different samples. The CRI has been established with just 8 samples. Okay, but yes, we know how to do that. I don't know that the price will be the same if you do a cheap design or if you do a very expensive design, but it depends how much you pay also your doll here. If you paid very expensive, well, most probably also the lighting design is very expensive. Museums, this is also other interesting thing. In museums, you need to see the different artworks. Usually, beginning of 20th century, museums was accessible only during day, and all museums had roof openings to have daylight. And many museums beginning of 20th century, they didn't have any artificial lighting system. Okay? Now we change that, and here you have some standard constraints. You have to circulate around. You need to create some ambience. You need to eliminate, of course, the artifacts here in order to create dramatic impressions and attract people to look that. But you have to respect the artwork. You don't have to overheat, no infrared. You don't have to have aggressive wavelengths, not so much blue and UV, because you can destroy the artwork. You not have to over-eliminate some very sensitive things, for example, old manuscripts or things like that with huge quantity of light, because sometimes the inks can be affected by even the visible part of the spectrum. And then you have different things. And of course, as here you have many projectors, you have to be sure that also you avoid any kind of glare for the people who are inside. And here, for example, you have some guides that they can tell you at what height you have to put the different type of projectors in order to see that, how much light can arrive in this painting in order to avoid to glare the people and see here correctly. Well, I will not go into in the details, but just remain no infrared, not UV, no heat. Sports, indoor sport practice, for example, basketball, tennis, or what you need. Here, you have different things. You have spectators, you have the people playing here, and of course here you have some problems. You see you have reflections from the light source in the ceiling. You have to avoid that because it is very reflecting. If you play basketball and you have the glare, you don't see exactly what you are doing. You have also the judges. You have a number of constraints. They are very, very difficult. You have also high ceilings, and you need a lot of light. Usually here, LEDs started to be complicated because you need very high flux, and metal halide lamps that they have very high flux can be more appropriate. If you use metal halide lamps and the current is cut for a few milliseconds, then you need more than 10 minutes to switch on the lights, and you have to think about security. Same thing here for tennis, football stadiums. This is outdoor, but here, beyond all the constraints of big volumes, you have an additional constraint. If you are in a first category or national category football, what happens is, what happens simply, you may have TV recording the match. And today TV cameras, they are high resolution cameras at very high frequency, and they need excessively high illuminance on the grass. To have a TV camera recording there for TV in a real time or even pre-recorded and display after, you need to have minimum 2000 lux on the grass. This is not a need for the players, but it's a need for the TV. And as the TV is the main revenue for that kind of games, you respect first the TV and then the other needs. Okay, stairs. Here the main thing is to guide, also to illuminate. You see the guidance here. You illuminate also from above. Here you have a lot of non-uniformity, but this is not a problem because you are in the flat area. But here is not a good point because non-uniformity in the stairs can be problematic. Bathrooms, okay? The problem here is not what kind of light you want, but is one, you have a place that you don't need to eliminate in permanent situation, and then you have another problem, which is that one, no electricity, nearby water. And then you need to define spaces, like here or around there, that you need to take into account what class of electrical protection hazard you have to take into account for your how to say, to eliminate for your fixture or lamp. That's all. Oh yes, I had here a couple of exercises. Let's look. This is funny. Here, find the type of lighting source eliminating that. What you can say here. This one, according to you, what is? What kind of lamp eliminate that? No, it's a sodium lamp. That one, most probably, is a very high CCT LED, and this one is a neutral white LED. This one, very low color temperature, very low RA rendering. This one is more sodium lamp. For the following lamps, which one is appropriate for a luxury workhouse? You have the color rendering and the color temperature. Well, if you look here, the best option, sorry, normally I have to have the answer, but the best option here is to use warm white with high rendering index. Most probably that one, okay? Okay, that is some of the questions that you have to ask when you want to start designing a lighting system. You have to look what are your needs and how you eliminate that. Okay, it's 11:20. It was long. I propose to stop for 10-15 minutes, and then last sequence that will take around an hour. I will speak to you about circular economy in lighting and also life cycle assessment, how we can calculate to a standardized way what is the impact of the lighting system that I decide to install inside one place or inside a street, everywhere you want to eliminate. You have to take that into account, and life cycle assessment includes also all the electrical items. Okay, let's stop. We recombine at 35. It's okay. 11:35, 15 minutes. And at the end, you will have a small